Are you struggling with an Angular interviews? In this video, I will show you short and simple notes that I use to prepare for my own interviews. We will cover important topics like components, services, RxJS, and many more. And not just the answers, I will also show you how to explain them clearly to the interviewer. These notes help me to get selected in big companies and they can help you too as well. Watch the full video to get the link, download this full ebook. Let's start now. A component in Angular is the basic building block of the UI. It controls a section of the screen and consists of three key parts: HTML template for layout, TypeScript class for logic, CSS or SCSS for styling. Each component is defined using the @component decorator, which includes metadata like selector, template, and styles. For example, in my recent projects, I have structured pages using parent-child components, each handling a specific responsibility like listing data, editing forms, or showing details. This modular approach improves maintainability and reusability. A decorator in TypeScript or Angular is a special function prefixed with that adds metadata or modifies behavior of a class, method, or property. In Angular, we use decorators like @component, @ngModule, @injectable, and @input to define structure and handle communication between components. For example, @component tells Angular this class is a UI component and holds metadata like template and selector. In one project, I even wrote a custom method decorator to log execution time of API calls. This helped us optimize performance without cluttering business logic. So, decorators make our code more modular, clean, and powerful, and they are core part of Angular development. There are multiple ways to share data between components in Angular, depending on their relationship. Parent to child. Using @input decorator, the parent passes data via property binding. Child to parent. Using @output decorator with event emitter, the child emits events that parents listen to. Sibling to sibling or unrelated components. I usually use a shared service with RxJS subjects or behavior subjects. It allows reactive data communication. Using view child. When the parent needs direct access to a child component's method or properties. Route parameters or query params. Useful when navigating between components with dynamic data. Local storage or session storage. When data needs to persist across refresh or logout. In my projects, I most commonly use input-output for tightly coupled components and a shared service for decoupled communication, especially for features, real-time updates, or cross-component messaging. The main difference is that promises are eager, single value, and not cancelable, while Observables are lazy, can emit multiple values over time, and are cancelable. In Angular, especially with HTTP calls and reactive forms, observables are preferred because of their flexibility and powerful RxJS operators. For example, a promise resolves once, like getting a response from an API, but with an observable, you can handle streams such as live search, WebSocket data, or value changes in forms. Also, observables are cancelable, which helps with memory leaks when we unsubscribing during ng on destroy. Promises don't offer that control. In my projects, I have used promises mainly for one-time actions like token refresh and observables for everything reactive, especially when chaining multiple async calls or handling user inputs streams. In Angular, we often use RHJ subjects and behavior subjects to share data or events reactively across components and services. A subject is both an observable and observer. We can emit values using next method and also subscribe to it. However, it does not hold the current value, so new subscribers won't receive any previously emitted value. A behavior subject, on the other hand, holds the current value and emits it immediately to any new subscribers. It is initialized with a default value, which makes it ideal for scenarios like maintaining state across components. In my projects, I commonly use behavior subject in a shared service for user login state, cart updates, or sidebar toggle state, where components need access to the latest value anytime. For example, if a user logs in, we emit the new user object via our behavior subject, and multiple components can instantly react to it, like updating headers, menus, or dashboards. So, in short, use subject for events, use behavior subject for state. In Angular, a service is a class used to organize and share business logic, reusable code, or data across components. It helps us separate concerns. So instead of placing logic inside a component, we move it into a service and inject it using Angular's dependency injection system. I typically use services for things like API calls using HTTP client, shared state management, data transformation, and utility functions. To make a service injectable, we use at the rate injectable decorator. In my experience, keeping services modular improves code reusability, testability, and maintainability, especially in large scale apps with multiple features and shared data. In Angular, a module is a container that groups related components, directives, pipes, and services together. It helps organize the application into cohesive blocks of functionality. Every Angular app has at least one module, the app module, which bootstrap the application. We can also create feature modules to encapsulate a specific functionality like user management or dashboard, and shared modules to hold reusable component and pipes. Modules uses the ng module decorator to declare metadata like declarations, imports, providers, and bootstrap. In larger apps, I follow a lazy loading strategy for feature modules to improve performance and reduce initial load time. So, modules are key to Angular's scalability and maintainability. They promote separation of concerns and better code organization. Are a way to transform data directly in the template, like formatting dates, numbers, or strings, without changing the actual date in the component. For example, amount currency display a number as currency, and today and date short formats a date. These are called built-in pipes. We can also create custom pipes using the pipe decorator and implementing pipe transform for specific formatting or transformations like masking phone numbers or filtering list. In one of my projects, I built a custom pipe to format status label based on API values like in progress to in progress, improving UI readability without adding logic to the component. In Angular, directives are used to add behavior or manipulate the DOM. They are one of the core building blocks of Angular, just like components. There are three types of directives. Component, technically a directive with a template. For example, any component you create is a directive under the hood. Structural directive. These changes the layout by adding or removing elements, for example, ngif, ngFor, and ngSwitch. Attribute directives. These change the appearance or behavior of an element. For example, ngClass, ngStyle, or a custom directive like highlighting or formatting input. In my project, I have created custom attribute directive like highlight directive to visually mark from errors and use structural directives for dynamic UIs. So in summary, directive allow us to encapsulate logic and extend HTML behavior in a clean and reusable way. In Angular, every component goes through a series of life cycle phases from creation to destruction. Angular provides life cycle hooks so we can tap into these stages and add custom logic. The most commonly used hook is ngOnInit, which runs after the component's input are set, perfect for initializing data or calling APIs. There are also on changes, which runs when at the rate input value changes, and on destroy, which is great for cleanup tasks like unsubscribing from observables or clearing intervals. Other hook like do check, after view init, and after content init give us fine grained control over change detection and template rendering. In real projects, I used ng-on-init for initialization, ng-on-destroy for cleanup, and occasionally ng-after-view-init when working with DOM or view child references. What is RxJS operator? RxJS is a core to Angular's reactive programming model, especially when working with observables from HTTP, forms, and events. Operators help us transform, filter, and combine these streams. I use them heavily in services and reactive forms. For example, I use map to transform API responses before passing them to the component. Switch map is my go-to in search boxes or autocomplete. It cancels previous requests and switches to the latest. Debounce time and distinct until changed are great in reactive forms to avoid unnecessary API calls while typing. I have used merge may when I need to handle multiple parallel API calls. Catch error is essential for global error handling, often inside interceptors. In one project, I used a combo of debounce time, switch map, and tab to optimize a live surge feature with minimal load on the server. What is HTTP interceptor? HTTP interceptor in Angular is a spatial service that sits between the application and the backend. It intercepts all outgoing HTTP requests and incoming responses, allowing us to modify them globally. For example, I use interceptors to attach authentication tokens like JWTs to each request, handle global error responses, and show or hide loaders during API calls. Tactically, interceptors implement the HTTP interceptor interface and are provided using HTTP interceptors in the module. In one of my projects, I created a token interceptor that checked for a token in local storage and added into the request headers. I also had a separate error interceptors to catch HTTP errors like 401 or 500 globally and redirect users or show toast messages accordingly. The biggest advantage is that I can handle cross cutting concerns like authentication, logging, and error handling in one centralized place, making the code base much cleaner and scalable. What is Jenkins? Jenkins is an open source automation tool that we have used for setting up CI or CD pipelines in our Angular projects. Whenever code is pushed to GitHub, Jenkins automatically triggers a pipeline to build, test, and optionally deploy the Angular app. In my experience, the Jenkins pipeline for Angular typically runs npm install, ng-bin configuration, production, and ng-test as part of the CI step. Overall, Jenkins helps us automate repetitive tasks, catch issues early, and maintain stability during development and releases. What is JSON? JSON or JavaScript Object Notation is the standard data format we use to exchange data between the front end and back end in Angular applications. In Angular, most APIs return data in JSON format. We use Angular HTTP client to make API calls, and the response is automatically passed into a JavaScript object from JSON. For example, when we call this.http.get method, it returns an observable of the passed JSON response. In one project, we had a dynamic form builder that consumed JSON schema from the backend to render form fields dynamically. So JSON played a key role beyond just data exchange. I am also comfortable working with JSON.stringify and JSON.parse when we need to store or retrieve structured data from local storage or session storage. is chain detection. Chain detection in Angular is the process that keeps the component's view in sync with its data model. Whenever an event occurs, like user input, HTTP response, or timer, Angular automatically runs chain detection to check if data bound properties have changed and updates the DOM accordingly. By default, Angular uses the zone.js library to patch async operations and trigger this process automatically. I have worked with both chain detection strategies. Default, which checks the entire component tree. On push, which improves performance by checking only when input references change. In large applications, I prefer on push with immutable data patterns or behavior subject strings to control by and what gets updated. This has helped improve performance significantly. I have also used chain detector ref and mark for check method when dealing with custom events or manual updates, especially in classes like dynamic content models or third-party libraries. What is Docker? Docker is a tool I have used to containerize Angular applications, meaning we package the app with its environment so it's run the same everywhere from local to production. In Angular projects, I typically use Docker to create a container that runs a production build of the app using ng-build, then serve the static files using a lightweight web server like Nginx. The benefit is developer, tester, and DevOps all use the same consistent container image, avoiding its works on my machines with. In some projects, we integrate Docker with Jenkins pipeline so that after successful Angular build, Docker automatically builds and pushes an image to registry for deployment. What is routing in Angular? Routing in Angular allows us to create a single page applications where navigation between views happens without reloading the entire page. I have worked extensively with Angular Router to define routes using router module and map URL path to specific components in the app routing module. For example, a simple route might look like path user component. I regularly uses features like route parameter for dynamic URLs like user ID, child routes or nested routing to structure complex modules. Route guards like auth guard and can deactivate to protect routes. Lazy loading or loading feature module only when needed, improving performance. Query params and fragment for handling filter or score position. In one project, we implemented a role-based routing system where guards are checked user roles before navigating. This improved both security and user experience. JWT or JSON Web Token is a compact token format used for securely transmitting information between client and server, typically for authentication. In my Angular project, JWT is commonly used after the user logs in. The backend returns a token which I store in local storage or session storage. For every subsequent API call, I attach the token in the authorization header using an Angular HTTP interceptor. The backend verifies the token to ensure the user is authenticated. I also decode the token on the client side to get basic info like user role or token expiration. This helps in implementing role-based access control and auto logout. To protect secure routes, I use route guards that checks if a valid token exists before allowing navigation. In one of my recent apps, JWT helped us implement a stateless auth system, improving performance, scalability, especially in microservices setup. What is error handling in Angular? Error handling in Angular is about catching and managing expectation gracefully, especially during HTTP call, user actions, and unexpected behaviors. I commonly handle errors using RxJS operators like catch error and retry in services. For example, if an API fails, I catch the error, log it, return a fallback or user-friendly messages. I have also implemented global error handling using Angular's error handler class. By extending it, I can log errors to external services like Sentry or show a notification those to user. For HTTP specific errors, I use a custom HTTP interceptor to catch common issues like 401 or 500 responses and redirect user to login a page or error screen. In one of my projects, we added user-level error tracking with error IDs. This helped the support team to trace issue quickly. Overall, I focus not just on catching the errors but also logging, notifying, and recovering without breaking the user experience. Angular provides two approaches for building forms, template driven and reactive forms. I have worked with both, but I prefer reactive forms for large and dynamic applications because they offer more control and testability and flexibility. Template driven forms are useful for simple use cases. They rely on directives like ng model and are mostly HTML based. Reactive forms, on the other hand, are built using form group, form control, and form builder in TypeScript, making them easier to validate, dynamically build, and unit test. I regularly implement form validation using built-in validators like validators.required, validators.pattern, and custom validators for things like email checks or business rules. I have also worked with dynamic form generation from JSON data and implemented real-time validation, conditional fields, and form arrays for complex form structures. In one project, we built a multi-step form wizard using reactive forms with centralized validation and step-by-state management. It improved user experience and reduced bug-related bugs. What is Angular Universal Server-Side Rendering? Angular Universal enables server-side rendering for Angular applications, unlike the default Angular setup which renders everything in the browser. Angular Universal renders the app on the server first and sends the fully rendered HTML to the client. This improves initial load performance, SEO, and supports better social media preview since scrollers and bots can be fully rendered content. I have implemented Angular Universal using the @ng Universal Express Engine package. The app runs on Node.js Express server which handles requests and returns re-render HTML. In one of my projects, we use SSR for public-facing e-commerce site. After enabling Angular Universal, our Google indexing improved and we saw better core web vitals scores. I am familiar with handling SSR specific challenges like managing browser only APIs, example window document, lazy loading, and ensuring hydration does not break interactivity. Overall, Angular Universal is a great choice when you need better SEO, faster first sprint, or optimize sharing on social platforms. What is data binding in Angular? Data binding in Angular is how we connect the component's TypeScript logic with the HTML template so that changes in one reflect in the other. Angular supports four main types of data binding. Interpolation for displaying dynamic values in the UI. Property binding to bind DOM element property like image src or disabled state. Event binding to handle user actions like clicks or input changes. Two-way binding combines property and event binding, mostly used in forms for real-time sync between UI and model. In my projects, I often use interpolation and property binding for displaying dynamic data, and two-way binding in the template-driven form. For reactive forms, I bind values using form control instead. Data binding plays a key role in keeping the UI responsive and in sync with the data layer. It is one of the reasons Angular is powerful for building dynamic single page applications. What is dependency injection? Dependency injection in Angular is a design pattern that allow us to inject dependencies like services into components or other services rather than creating them manually. Angular has a built-in DI framework and we typically register service using the @injectable method decorator with providing root to make it available globally. For example, if I have a user service, instead of creating a new instance inside a component, Angular injects it via the constructor, promoting loose coupling and easier unit testing. I also use GI to inject things like HTTP client, custom config tokens, or activated route into components and services. In large apps, I have many feature level and component level providers using ng modules and component level providers. Array when scoping is needed. I am also familiar with using injection token for injecting configuration on multi-provider values. Overall dependency injection help us write clean, reusable and testable Angular code, and it is fundamental up to how Angular applications are structured. What is a standalone project in Angular? In recent versions of Angular, starting with Angular 40, we can build apps using standalone components without relying on ng modules. This is what we refer to when we talk about a standalone project. In a standalone Angular project, components, directives, and files can be marked with standalone true, and they directly import what they need, which simplifies dependency management and reduces the need to create feature modules. I have used standalone components in newer projects to build lightweight, faster to load apps. For example, instead of declaring components in a module, I just import them directly where needed. Angular CLI also supports generating standalone components using the standalone flag, and routing can be configured using the new provide router method. This has helped us reduce boilerplate, make components more usable, and improve tree shaking during builds. It also aligns Angular more closely with modern frameworks like React in terms of simplicity. So, in summary, standalone architecture in Angular makes X simpler, faster to scaffold, and more maintainable, especially for micro frontends or modular enterprise apps. What is synchronous and asynchronous in Angular? Synchronous operation in Angular like variable assignment or function calls happen in a blocking manner where one task completes before the next starts. Asynchronous operations are non-blocking. Tasks like HTTP calls, timers, or user events run in the background, and Angular continues executing the rest of the code. Angular handles async operations using RxJS observables. For example, when I use HTTP client bot.get, it returns an observable, and I subscribe to it when the data is ready. This is crucial for building reactive performance apps. I have also used async a bit with promises for scenarios like fetching config data before app initialization. Understanding the difference helps avoid issues like trying to access async data before it is available, which can lead to undefined errors. In one project, we use POC join to make parallel API calls and wait for all of them to finish before entering the view. A perfect real world use for async programming. What is async and await in Angular? Async and await are keywords in TypeScript used to handle promises in more readable, synchronous looking way. When I mark a function as async, it always returns a promise. Inside that function, I use await to pause execution until a promise resolved, which helps write cleaner, more readable asynchronous code. In Angular, I mostly use async await scenarios like fetching data during app initialization, example app initializer, calling promise based libraries, performance sequential async operations where readability matters. What are signals in Angular? Signals are new reactivity model introduced in Angular 16 that allow component to reactively respond to state changes in a fine-grained, effective way, similar to use state in React or reactive variables in SolidJS. A signal is a spatial wrapper around the value that can be read and updated, and Angular automatically tracks dependencies and re-renders only when that specific signal changes. In real use, I have used signals in place of behavior subject for lightweight local state like counters, filters, or UI toggles, reducing complexity and improving performance. Signals also integrate with computed for the right values and effect to run side effects when signal changes. Compared to iterate import for observable, signals offer a more declarative and automatic way of tracking changes, and they play well with on-push change detection. I see Signal has a future of Angular's reactive state handling, especially for building fast and predictable UIs.